What's up? All right, what's up, AP Physics 1? Today we're going to be applying our knowledge of circular motion into problems. Okay, so without further ado, let's get started. Let's get a problem up in here. Okay, so the problem is, what is the maximum speed? The max speed, so that's pretty much the question. The max speed, and let me put a dot here. The max speed with which a 1,200 kilogram car can round a turn of a radius of 90 meters. So of a 1,200 kilogram car can round a turn of a radius, can round a radius. Let me rewrite that. Can round a radius of 90 meters. Okay, and on a flat road, if the coefficient, so on a road, if the coefficient, now I don't really want to write the whole word, so I'll just say mu. Mu is another way of writing coefficient. So the coefficient of friction between the tires, so the coefficient of friction between the tires and the road is 0.65. Okay. So that is our question. And it's asking, so our question is asking for the maximum speed. So we have to basically find something with a velocity in it. But rule number 1 of physics, for all of you that have been watching my videos, this is getting very, very repetitive. But always draw a diagram. So we will quickly draw a effort of a diagram. So we have some sort of circular path that a car is traveling on, and we have a car. We can just draw a car here. All right, we have a car, and it's traveling on the circular path. This circular path, it says, if we assume the center is here, this circular path has a radius of 90 meters. Okay, it has a radius of 90 meters. And we also know that the coefficient of friction is 0.65. So they're bringing in a force here. They're bringing in a frictional force into this whole circular motion problem. So we know that not only do we need a full diagram of what's happening in the problem, but we also may need to blow this up and draw a free body diagram of what's happening in this problem. Okay, so if we were to draw another circular path and draw this car, just zoom in on the car. Let's draw all the forces that are acting upon this car. So we have gravitational force, we have a normal force that the road is providing on the car. We don't have an applied force, but we do have a frictional force. All right? So we have all these different types of forces acting on this car as it moves along this circular path. So they're asking us for our maximum speed. Our maximum speed. So the best thing we can do now, remember in chapter 4 in dynamics, how whenever we drew a free body diagram, we always derived equations. Let's derive some equations. So we know that Fg and Fn have to be equal to each other. Why do they have to be equal to each other? Well, because the car is traveling on the road. If Fg was greater, then the car would be braking the road. The car would fall through the road. And if Fn was greater, then the car would be flying upwards. It would be accelerating upwards. But since both of those are not happening in this problem, we know that Fn has to equal Fg. We also know that there is a net force on this car. And because it's in circular motion, we can assume that this net force has a centripetal acceleration. Okay, so we would rewrite this. So its net force is equal to some value. We're not really sure about, we don't have a value here, so we would say it's 0. Minus this frictional force. Minus this frictional force. So we have two derived equations, and we need to find our maximum speed. Now, a question that I got from the previous video is, hey, why can't you write this F net as Fc? Why can't you write it as our centripetal force? Isn't centripetal force the same as your net force? Because centripetal force is nothing but mv squared over r, and we know that our net force is m times m times our centripetal acceleration, which is m times v squared r, or mv squared r. So these two things are equal to each other. And I said you absolutely can call it the centripetal force. Absolutely you can. In fact, that would be more appropriate since we're talking about circular motion. So another way you could draw this, another way you could write it is by saying Fc is equal to negative, or the opposite of our frictional force. Okay, so that's another way that you can write it. So just to add some variety, because we've been doing a lot with this summation of all forces, let's work a little bit with centripetal force. Let's use this equation. So our centripetal force is equal to this the opposite of our frictional force. We want to find our maximum speed. So can we simplify or rewrite these two forces, expand them per se, to maybe solve for a velocity variable? Well, we know that centripetal force is equal to the mass times the velocity squared, or let's actually rewrite this as mass times mass times velocity squared over r. Let's rewrite it like that, and you'll see why in a bit. It doesn't matter how you write it. You can write it mv squared over r, but I would prefer to write it like this, and you'll see why in a bit. Frictional force, we know from our dynamic days, from our days learning dynamics, we know that that's nothing but mu, or the coefficient of static or kinetic friction, but it's the coefficient of friction times our normal force. So we will do that. We will do our coefficient, our mu, times Fn. All right, so can we simplify Fn into anything? Well, hey, Fn is equal to Fg. Another way you can write Fg is m times g, mass times our gravitational acceleration. So you could rewrite this equation as our centripetal force times the opposite of our mu times mg. Okay? Now what we can do is we can factor out an m. So factor out an m, we already kind of factored out an m here. We can factor out an m here times our negative mu g. We could, and then cancel, and then m times v squared over r. And we could, if we divided both sides by our mass, we could cancel out our mass. So we really don't need the mass of this car. We don't need to have a mass to solve this problem. This 1,200 kilograms is really extraneous information. You don't need it to solve the problem. Okay, you could just cancel out that mass. Would you get the same result if you popped in this 1,200 kilograms? Absolutely you would. But why would you want to do more work? Okay, you might also be in a time crunch, so why do more work? So you could simplify this into v squared over r equals negative mu g. Okay, so are we given a velocity? No, in fact, we need to find a velocity. So v squared, are we given a radius? Yes, we are given a radius of 90 meters. Okay, we are given a radius of 90 meters. And this equals our negative coefficient. And actually, in fact, we're given a coefficient of 0.65. Okay? And our gravitational acceleration, we can consider it to be negative 9.8. You can consider it to be 9.8. It doesn't really matter. Since we're accelerating downwards, you can say negative 9.8. So this will become a positive number. So 0.65 times 9.8 equals 6.37. Now, you may have a problem with putting a negative here because usually you don't put a negative here. Usually you don't put a directional quantity when you're doing a dynamic related problem. So if you are not comfortable with that, you can just put a negative 0.65 times 9.8, but whatever value you get will be negative. So that may have an effect on your value. So you have to convert this negative value into a positive value. Okay, so just convert the negative into positive. It's not a big deal. All right, so we get 6.37, and we have to multiply that by 90. So multiply both sides by 90. Multiply both sides by 90. And you would get v squared to equal 6.37 times 90, which is 573.3, so 573.3, okay? And you take the square root of both sides because you just want velocity, And the square root of 573.3 is equal to 23.94 meters per second, 23.9 meters per second. And that would be your answer.